Am I audible to you?
Yes, sir.
Am I audible to you? Ayush,
Yes, sir.
Danish, Jishan.
Yes, sir. You are audible to us.
Okay. Good morning to everyone. Our today's topic is DC motor. First, we have to understand the working principle of DC motor. First, we have to understand the working principle of DC motor. First, tell me, is there any difference in construction in between DC generator and DC motor? Ayush, Khushbu, just tell me, is there any constructional difference between a DC generator and a DC motor? Khushbu, Ayush, tell me, is there any constructional difference between DC generator and motor?
No, sir.
No. Good. So, first we have to understand the working principle of DC motor. Actually, the working principle of DC motor is based on the left hand rule of Fleming. Or actually, the working principle of say DC motor is based on the left hand rule of Fleming. So, what is the Fleming left hand rule? Suppose we have stretched our left hand three finger, the forefinger, thumb, and the middle finger. We are stretching these three finger 90 degree with respect to each other. And if the direction of the magnetic field is denoted by the forefinger, and if the direction of current passing through a conductor is denoted by the middle finger, then we can say the deflection of the conductor, or say direction of the force on that conductor is directed by the direction of thumb. So what we say, actually what I say at that time, if the forefinger is directed the magnetic field, and if the direction of the current is denoted by middle finger, then the deflection of the conductor is directed by the thumb. Then we can see in a motor that two force, the two forces are act into different conductor. So if two different force is acting like that, then a torque is produced, and the DC motor will rotating with some speed. देखो समझ में आया मनीष, आयुष? समझ में आया? मान लीजिए मेरे पास लेफ्ट हैंड है, लाइक दैट फिगर. इफ द फोर फिंगर इज डायरेक्टेड द मैग्नेटिक फील्ड, मतलब फोर फिंगर मैग्नेटिक फील्ड के डायरेक्शन को दिखा रहा है, और मान लीजिए एक कंडक्टर है, उससे जो करंट जा रहा है वो मिडिल फिंगर की तरह डायरेक्शन में है, तो कंडक्टर का डिफ्लेक्शन किस तरफ होगा? थंब जिस तरफ है उस तरफ. ये तीनों उंगलियां 90 डिग्री में है. ये तीनों उंगलियां तो हम 90 डिग्री में पहले स्ट्रेच किए. फिर अब अगर मान लीजिए मैग्नेटिक फील्ड का डायरेक्शन फोर फिंगर से हम डिनोट करेंगे. फिर करंट जो जा रहा है कंडक्टर से, वो अगर मिडिल फिंगर से हम डिनोट करेंगे, तो वो जो कंडक्टर डिफ्लेक्ट होगा वो कौन सा तरह होगा, और किस तरफ होगा? तो थंब की डायरेक्शन में होगा. तो खुशबू अब समझ में आया? देखो, if we placed if I placed a current carrying conductor in magnetic field, and a force is developed on that conductor, and which direction it is deflected, actually we can get that direction from Fleming left hand rule. आयुष,
यस सर.
समझ में आया? बोलो. ये
हाँ सर.
ये समझना पड़ेगा, नहीं तो डीसी मोटर समझ में कुछ नहीं आएगा.
सर वो क्रॉस प्रोडक्ट वाले से भी तो निकल जाएगा.
कौन?
क्रॉस प्रोडक्ट फोर्स होता है मेरा आई डी एल क्रॉस बी, तो डीएल करंट का डायरेक्शन में है और क्रॉस बी करेंगे तो फिर वो फोर्स का डायरेक्शन सेम उसी तरह निकल जाएगा.
हाँ, ये कह सकता है. वो एक्चुअली वो क्रॉस डॉट अभी सबको तो समझ में नहीं आता, वो सब बाद में. और ये जो आप मैग्नेटिक फील्ड जो पढ़ रहे हैं ना, इलेक्ट्रोमैग्नेटिक फील्ड थ्योरी, उसमें उससे समझिए तो आसानी होगा. लेकिन जब मशीन के बारी आएगा तो तब आपको बोलना है ये फ्लेमिंग लेफ्ट हैंड रूल से चलता है. आप अगर क्रॉस प्रोडक्ट बोलेंगे तो ये आंसर सही नहीं माना जाएगा. तो आपको तब बोलना है द प्रिंसिपल of DC motor is based on the Fleming's left hand rule. रूल क्या है? अगर मान लीजिए फोर फिंगर से हम मैग्नेटिक फील्ड का डायरेक्शन दिखा रहा है एंड वो कंडक्टर जो है उसमें जो करंट जा रहा है वो फोर फिंगर से हम डिनोट कर रहे हैं, तो कंडक्टर का डिफ्लेक्शन किस तरफ होगा? थंब की तरफ होगा। ये समझ में आ गया ना?
यस सर, वो तो।
ओके, सो based on that theory we can see the direction of the force, the direction of force of two sides of a coil is denoted by this yellow arrow. We can easily see if two forces are acting in a same body with some distance, then a torque will produce on that object. Here a coil, that means that there is a torque produced on that coil. Due to this torque, the due to this torque, the DC motor will rotate in a direction. In which direction? Either it is uh, rotating clockwise or anti-clockwise. What is the direction? Clockwise or anti-clockwise? We can find by using the principle of left-hand rule of Fleming. By Fleming left-hand rule, we can determine the direction of rotation of DC motor. इस कंडक्टर में आप वो रूल अप्लाई कीजिए, देखिए क्या होता है इस कंडक्टर में। इस कंडक्टर में रूल अप्लाई कीजिए, क्या हो रहा है देखिए।
क्लॉकवाइज सर।
वो डायरेक्शन अपवर्ड हो रहा है ना, लेफ्ट हैंड स्ट्रेच कीजिए, देखिए ये ऊपर ही जा रहा है ये कंडक्टर, और ये कंडक्टर किस तरफ जाएगा?
डाउनवर्ड।
डाउनवर्ड जाएगा। द डायरेक्शन ऑफ दैट कंडक्टर इज डाउनवर्ड, सो द रिजल्टेंट रोटेशन इज क्लॉकवाइज if we see from the side of commutator. This is basically commutator. These two are commutator. If we see from that commutator side, then we can see the motor will rotate in clockwise direction. This is the working principle of a DC motor. Now, my next topic is back EMF. करंट का डायरेक्शन किस तरफ होगा? In which direction, in which direction we denote the current, towards or outward? Manish,
टुवर्ड्स सर।
because we are talking about
डीसी
DC
मोटर।
motor, so the direction of the current is inward. And what is the equivalent circuit? If we apply V voltage, and if the current flowing through is IA, this is VB, this is RA, and this is EB. Now tell me what is the Now tell me the equation which we get from applying Kirchhoff's voltage law, KVL. If we apply the Kirchhoff's voltage law, what we get actually? If we apply
So
KVL, then what we will get?
V is equal to VB plus IARA plus EB.
V is equal to V is equal to
So VB
let me V is equal to what is the equation? V is equal to EB plus IARA plus EB. And if we neglect the brass voltage drop, then what we get? Means if we neglect brass voltage drop, what we get?
what, sir?
If we neglect the brass voltage drop, then what we get? V is equal to
EB
EB plus
plus IARA.
IAR. What is the name of that equation? This is called motor equation. Just write down. This is called motor equation. Actually, in DC motor, what we are actually doing? We are applying a magnetic field, or we are creating a magnetic field, and we rotate a conductor or say armature on that magnetic field. What will happen? Ayush, tell me what will happen after applying the magnetic field, or say after creating the magnetic field. If we rotate the armature, what will happen? Manish, what will happen?
Sir, voltage will produce.
Yes, good. The voltage is induced, and the name of that voltage is called rotational EMF. What is called rotational EMF, and it is denoted by ER. Actually, whenever we rotate a conductor in a magnetic field, then there is a induced voltage, and the name of that induced voltage is rotational EMF, because this induced EMF is produced due to the rotation. Whenever we rotate a conductor or say armature in a magnetic field, then a voltage is induced on armature, which is called rotational EMF. In case of DC generator, that rotational EMF called generated EMF, and it's denoted by EG. It's denoted by EG. And in case of motor, that induced EMF is called back EMF, because This back EMF is oppose the applied supply voltage, or say opposing the applied voltage. That's why this voltage name is back EMF. So in case of motor, the rotational EMF is called back EMF. So if someone's questioning you what is back EMF, so your answer should be like that. In case of motor, when we rotate the armature in flux, then a rotational EMF is induced on that armature. This rotational EMF opposes the supply voltage. So this EMF is called back EMF, or that's why this EMF is called back EMF. So the expression of back EMF is what? Tell me. Manish, it's similar like induced voltage. ER is equal to EG is equal to EB. And what is the expression? P I N Z by A. This is the equation. I hope it is clear to you all. Ayush, Manish, Khushbu. Ayush, now
Yes,
can
sir.
you tell me what is back EMF? Can you tell me?
So the opposing EMF, sir.
The opposing EMF, first start from the motoring operation, then say that EMF is opposing the supply voltage. That's why we say this EMF is back EMF. Start from, actually you have to start from the operation principle. That means suppose there is a magnetic field and we rotate the armature, then an induced EMF is produced, then an induced EMF is produced on armature. This induced EMF opposes the supply voltage. That's why this EMF is called back EMF. And the expression of back EMF is similar to the generated EMF, is equal to similar to rotational EMF. Is P phi NZ by A. Here we use the small a. That means the small a is what is what is actually denote the small n?
Speed of armature in second.
In RPS.
Second. Yes. Rotation per second.
Good. Now our next topic is torque equation. Then write down the heading torque equation. What we get from motor equation, or tell me the motor equation. You can write from motor equation we get V is equal to EB plus
EB plus IAR.
IAR. if we multiply if we multiply this equation by IA, if we multiply this equation by IA, what we actually get? Tell me. After multiplying by IA in both sides, what we get? Tell me.
Power equation.
No, no, just tell me the equation first.
IAB
Yes, VIA
equals to
is equal to
IAEB plus RA.
EB into IA,
Yes,
then
plus RA.
then IA square. RA. Now tell me what is that? Suppose if we apply, or say suppose we if we multiply voltage into current, what is actually this quantity?
Power.
Power. And what is V actually? The supply voltage. If we apply, or if we supply a V voltage, and what is IA? What is IA? The armature current. So can I say that this is input power? Can I say this is basically input power, because we are supplying the terminal voltage V, and a armature current is flowing. So you can say what is our supply voltage at that time is V, and current, the value of the current at that time is IA. So we can say V into IA is the input power. And now tell me what is the name of that term? What is that? Have you ever seen this term?
Power, sir.
Yeah, this is also power. But suppose if we flow a current through a resistance, this power is actually our working power or loss power. हमारा एक मान लीजिए एक रेजिस्टेंस के थ्रू करंट भेज रहे हैं, तो उसमें जो पावर कंज्यूम होता है वो हमारा कोई काम का होता है कि वो हीट में लॉस हो जाता है?
Dissipated power.
Actually this power is consumed by resistance, and it will produce heat. Is there any function of heat in DC motor? Is there any function of heat? हीट का कोई काम है मोटर में? अगर मशीन हीट हो रहा है तो वो हीट क्या कुछ कम करता है या लॉस हो जाता है वो हीट?
लॉस होता है।
लॉस होता है, दैट मीन्स दिस पार्ट इज लॉस पार्ट, क्योंकि डीसी मोटर में हमें कोई हीट नहीं चाहिए। हम क्या चाहते हैं, जो हीट कम प्रोड्यूस हो। अगर हीट ज़्यादा प्रोड्यूस होगा तो वो एनर्जी लॉस हो जाएगा। दैट मीन्स वी डोंट वांट हीट, or say loss of heat we don't want. How much energy is losses due to the heat we don't want. So this part is loss part. If we know that there is a equation input is equal to something is there plus loss. What is that actually? Tell me. You know that equation, input is equal to, there should something,
इनपुट है,
what?
आउटपुट।
Output. Good. That means this term should be output. So now tell me, मतलब ये पार्ट क्या होगा? ये होगा आउटपुट। Actually, this is called the electrical equivalent of gross mechanical power developed by the motor. This is electrical equivalent of mechanical power developed by the motor. अगर मान लीजिए एक मोटर घूम रहा है ओमेगा स्पीड में, और वो जो टॉर्क डेवलप हो रहा है वो टी है, तो कितना पावर जनरेट करता है एक मोटर? कितना पावर जनरेट करता है? हाउ मच पावर इज जनरेटेड बाय ए मोटर इफ द एंगुलर स्पीड ऑफ द आर्मेचर इज ओमेगा एंड टी इज डेवलप टॉर्क? टेल मी. And the value of omega is 2 pi n. अगर मान लीजिए एक मोटर घूम रहा है ओमेगा स्पीड में और टॉर्क टी जनरेट कर रहा है, तो तब जो मैकेनिकल आउटपुट होगा, और मैकेनिकल, और यू कैन से द मैकेनिकल आउटपुट और मैकेनिकल आउटपुट पावर इज इक्वल टू टी इंटू ओमेगा। हम इलेक्ट्रिकल जो इक्वेशन था उसमें कितना आउटपुट पावर निकला, बोलिए? हाउ मच output power we are getting from the equation, electrical equation? How much power we get, or say what is the equation, is equal to eb into ia. Manish,
यस सर।
I can write like that.
यस सर, ए बी एम टू आई ए।
eb into ia, this is the output power, actually mechanical output power. And suppose if a motor rotate with angular speed omega and tau is the developed torque, then we can write the mechanical power is equal to tau into omega, or say t into omega. So from that equation we have to determine how much torque is developing. So we can write eb Ia by omega. What is the value of Eb? Or say what is the expression of Eb? Eb is equal to Manish
P and Z pi by A.
by A. If we put that value and that equation, what we get? P Z N phi Ia by 2 pi A into N. इसे हट जाएगा, फिर क्या आएगा? What is the final term actually? What we get? T is equal to Pz by 2 pi A into phi into Ia is equal to K phi Ia, you can say. Then at that time, what is the value of K? Manish,
Yes, sir.
what is the value of K?
Yes, sir. Pz by 2 pi A.
Yes, Pz by 2 pi A. And T is equal to K phi Ia. This equation is called torque equation. So what is the torque equation? T is equal to K I Ia. This is called torque equation. That means the developed torque is proportional to the flux and proportional to the armature current. And what is the value of K? K is Pz by 2 pi A. P is number of pole, Z is total number of conductor, 2 pi is constant, and A is, what is A? Manish,
Yes, sir.
what is the name of A? Actually, which quantity we are denoting by A?
Sir, length of conductor, sir.
No. Number of conductor is denoted by Z.
Length of conductor, sir.
No. Not length
So
of the
number of
conductor.
conductors in series.
A is Number of parallel path between two brushes. A is
Yes, sir. Yes.
A is H what? Ayush, what is the name of A? Or which quantity we denoted by A? Now tell me. A is number of parallel path between two brushes. I hope it is clear to you all. Ayush, have you understand?
Yes, sir.
Manish,
Yes, sir.
have you any question regarding this? Have you any question regarding this? This topic actually, the topic which I covered today, the working principle and the back EMF and the torque equation. Have you any question regarding this topic? Manish?
No, sir.
Okay. Then we move to the attendance part. Manish,
Present, sir.
Ayush,
Present, sir.
Jishan,
Present, sir.
Muskan,
Yes, sir.
Yash,
Present, sir.
Asgar,
Yes, sir.
Sohel,
Yes, sir.
Deepak,
Present, sir.
Praveen,
Present, sir.
Khushbu.
Present, sir.
Okay.